So the torsion for a curve in 3D that is given by negative dv by dt, the dot product of that with n, where p is defined as t cross n, where t is the unit tangent vector, that is it's the velocity vector upon its magnitude, and n is the vector normal to that in the plane of motion, that is n is equal to dt by dt, which I'll write as t dot but normalized, right? So dp by, so it's supposed to be dv by ds, where s is the arc length. So one can rewrite this thing as negative dv by dt dot n and then divided by ds by dt, which one can write as 1 upon v. So this is a dot product, this is a scalar multiplication. Now since d is t cross n, db by dt, that would just be t dot cross n plus t cross n dot. Now since n was defined as t dot upon the magnitude of t dot, this cross product is 0. So we are left with tau is equal to negative the dot product of this with n. So it's t cross n dot n, that upon v. Now this is a triple product and can be written as such. So it's just t n dot n and 1 upon v. Using this negative sign, we can flip two of these columns to get t n and n dot. Right. Okay. Now n is just t dot upon the magnitude of t dot, but that means that n dot is just minus t dot upon the magnitude of t dot squared, that times of t dot magnitude, the magnitude of that upon dt, plus t double dot upon the magnitude of t dot. Now this quantity is collinear with t dot, right? And t dot is collinear with n. So n dot n dots, this much of part is collinear with n, and so we can just eliminate that because we're taking a triple product, which is essentially determinant. So we do not need to care about this, and so it's equivalent to saying t double dot upon the magnitude of t dot. So rewriting all of this, what we can say is n dot is equivalent to t double dot upon the magnitude of t dot, n is equivalent to t dot upon the magnitude of t dot, and well, t is just t. So this turns out to be 1 upon v, the magnitude of t dot squared, and then this triple product t dot t double dot. Now we need to go one step beyond and use what t is. So t is r dot upon v, where v is the magnitude of r dot, right? So if t is that, t dot is just r double dot upon v plus r dot, the time derivative of 1 upon v, where v is a scalar. Similarly, t double dot would just be r triple dot upon v plus r dot d square by dt square of 1 upon v plus d r dot upon dt, which is just r double dot times t upon dt 1 upon v. Now notice that this and that, both of these can be created by linear combination of t and t dot, which means we can just ignore these. Similarly, in t dot you can ignore this. So t dot and t double dot can be equivalent to these. So our triple product just becomes tau equal to 1 by v magnitude of t dot squared, that times of 1 upon v cubed, and then this triple product r dot r double dot r triple dot. So we can rewrite this as 1 upon the magnitude of v square t dot squared, right? Now t is once again just r dot upon v, which means that t dot is just r double dot upon v, right, plus r dot d by dt of 1 upon v. But notice that r double dot is just the acceleration, and the r dot quantity, that is collinear with t. So it's something, let's call that capital A times t. Similarly, t dot is collinear with n, so that's something b times t, right? Yes. Or we can just let it be and let's just call this t dot. Sure. So then we can take a cross product of that with v. And so first we'll just multiply this by v. So just got t dot times v is equal to a plus at. Now let's take a cross product of that with v vector, or r dot for short. So we'll just have v t dot cross r dot, that's equal to a cross r dot, plus, now since r dot is linear with t, this term is 0, and so we can discard that. Also notice that t dot and r dot are perpendicular, and so this just turns out to be v times, so t dot is in the direction of n and r dot is in the direction of t. So the magnitude is of course just the norm of t dot, the norm of r dot, but the direction is it's similar to n cross t, which is minus of b. Right. So taking the magnitude on both sides, what we get is v t dot, and since this thing is just v, that is equal to the magnitude of a cross r dot. So essentially the magnitude of v square t dot, that is the magnitude of a cross r dot. So we can rewrite this thing as just the magnitude of the acceleration times the velocity vector squared. And this is the formula for torsion. I'll see you guys in the next video.